Today we're going to learn how to find the probability of independent and dependent events. We're going to define some vocabulary words first. Independent event is our first vocabulary word. Independent event is if the occurrence of one event does not affect the likelihood that other event or events will occur. So, probability of independent event is the probability of two or more independent events is the product of the probabilities. And this sounds like it's really hard, but when we start working it, I think it will make a lot of sense. So there's the words as Ms. Bernowski would write it. A mathematician would write it this way. The probability of A and B is the probability of event A times the probability of event B. So I think even just seeing it that way makes it a little bit more clear than the words. Dependent events are if the occurrence of one event does affect the likelihood the other events will occur. Alright, so the probability of dependent events is the probability of two dependent events, A and B, is the probability of A times the probability of B after A occurs. So there's the words as Ms. Bernowski would write it. And then for a mathematician, the probability of A and B equals the probability of A times the probability of B after A occurs. So let's look at our first example. Our first example is finding the probability of an independent event. It says you spin the spinner and flip the coin. What is the probability of spinning a prime number and flipping tails? Okay, so we have to do these as separate probabilities. So first I'm going to figure the probability of spinning a prime. And prime numbers are numbers that can be divisible by itself in 1. So probability is 2, or prime is 2, 3, and 5. So the probability of spinning a prime number, my favorable outcomes are 3, and then my total outcomes are 5. And then the probability of flipping tails for my second event is 1 favorable outcome out of 2 totals. So then my probability of prime and tails is probability of the first event times the probability of the second event. 3 times 1 is 3, 5 times 2 is 10. So that's 3/10, which is the same thing as 30%. So I have a 30% chance of landing on a prime number and getting tails. Go ahead and look at the on your own problem. What is the probability of spinning a multiple of 2 and flipping heads? Then use the spinner from example 1. So go ahead and pause the video, work that out, and come back and check your answers. Okay, so the probability of landing on a multiple of 2, my favorable outcomes are 2 out of 5 possible. The probability of landing on a heads is 1 out of 2. So then to find the probability of both events occurring together, 2 over 5 times 1 over 2 equals 2/10, which simplifies to 1/5, which is 20%. So I have a 20% chance of landing on a multiple of 2 and flipping heads. Example 2 says find the probability of a dependent event. So that's going to be a little bit different. People are randomly chosen to be game show contestants from an audience of 100 people. You are with 5 of your relatives and 6 other friends. What is the probability that one of your relatives is chosen first and then one of your friends is chosen second? Okay, so my first event is the probability of a relative being chosen. So there are 5 relatives. So I have a 5 out of 100 people that one of those people will be chosen. That simplifies to 1 out of 20. Okay, then the second part of that says, or second event, so then the probability that one of your friends is chosen. So I have 6 friends, but now my possible outcomes, since one person has already been chosen, my possible outcomes, there's now 99 people to choose from. So kind of think that in your head, how we went from 100 possible outcomes to 99. And then that simplifies to 2 out of 33. And the reason I'm simplifying them is because it's just easier to work with smaller numbers, especially when you're multiplying. So the probability of a relative being chosen first and a friend chosen second is 1 out of 20 times 2 out of 33. 1 times 2 is 2. Then in my calculator, I'm going to do 20 times 33, and that is 660. That simplifies to 1 out of 330, and I can do 2 ABC 660 to get that. Then to convert that to a percentage, 1 divided by 330 is 0.3%. So you can tell that the likelihood of a relative being chosen and then a friend being chosen is not very big. It's less than 1% that that's going to happen. The on your own says, what is the probability that you, your relatives, and your friends are not chosen to be either of the first 2 contestants? Go ahead and pause the video. I feel like this one is a little bit harder, so I will walk through this one, but pause the video and try this one on your own. Okay, so the question is, what is the probability that you, your relative, and your friends are not chosen to be either of the first 2 contestants? So we have, I'm going to do kind of a little side note down here. We have 100 people, and we want to know that I'm not going to be chosen, so that's -1. That gives me 99 people. Then my relatives are not going to be chosen. That's -5. That gives me 94. And then -6 for my friends. That gives me 88. So I have an 88 favorable outcome out of 100 people. That simplifies to 22 out of 25. Divide both of them by 4. Okay, then the second part of that is not your friend. So somebody has been chosen for the first pick. That reduces my favorable outcome to 87, and then my possible outcomes to 99 because somebody has been chosen. And then that simplifies to 29 out of 33. So the probability of not a relative and not a friend is 22/25 times 29/33. So multiply that on a calculator. 22 times 29 is 638. And then 25 times 33, do that on a calculator, is 825. That simplifies to 58 over 75, which is 77.3%. So you have a way better chance that you or your relatives or your friends are not going to be picked to be contestants on that game show. If you did not work through this on your calculator with me, I strongly recommend that you do that so you kind of see how the numbers play out and where the numbers come from. Example 3 says, find the probability of a compound event. A student randomly guesses the answer for each of the multiple choice questions. What is the probability of answering all 3 questions correctly? Okay, so you've got this quiz from social studies with 3 questions. So method 1 is probability of independent events, which is what we've worked on today. So probability of 1 2, and 3. So I have a 1 out of 5 chance for question 1, 1 out of 5 chance for question 2, and 1 out of 5 question chance for question 3. And the independent event says that I multiply them together. 1 times 1 times 1 is 1. 5 times 5 is 25. 25 times 5 is 125. Be careful in your calculator that you do not do 5 times 3. That is not what that is saying. That's 5 raised to the third power. So be really, really careful. That's a caution for you. And then in my calculator, I'm going to do 1 divided by 125, and that comes out to be 0.8%. So to get all 3 of those questions just by randomly guessing, I have less than a 1% chance that I'm going to get those right. Okay, then method 2 is our fundamental counting principle that we've learned a couple days ago. And that says that I'm going to find for question 1. And remember how I do these, I have like 2 columns. So I have 1 correct choice out of 5 correct answers. Then question 2, I have 1 correct choice out of 5. Then same thing for question 3, 1 correct choice out of 5. 1 times 1 times 1 is 1. 5 times 5 times 5 is 125. So the probability of 1, 2, and 3 guessing correctly is 1 out of 125, which equals 0.8%. So 2 different ways, even though I feel like they're very similar, 2 different ways to do that, and then notice that we get the same answer as we should. Go ahead and pause the video, do the on your own, and then come back and check your answer. Okay, the on your own says the student can eliminate choice A for all 3 questions. What is the probability of answering all 3 questions correctly? Compare the probability with the probability in example 3. Okay, so I just set mine up for the counting principle. That makes sense to me, and I like having my columns separate. So for question 1, I have 1 correct choice. And then now I'm able to eliminate 1, so I have out of 4 outcomes. Same thing for question 2, same thing for question 3. So 1 times 1 times 1 is 1. 4 times 4 times 4 is 64. So the probability of 1, 2, and 3 guessing correctly is 1 out of 64. And that 1 divided by 64 comes to be about 1.6% if you divide that on your calculator. So there's my probability for answering all 3 questions correctly if I just guess. And then to answer the second part of that, and I'll use a different color, the probability of getting 3 correct answers increases, which should make sense. And if you want to say increases from 0.8% to 1.6%, that's even better. All right, so that is our lesson for today. If you still have questions after taking notes, please come see me in the morning.